Example 2, a canoeist took 2 hours to travel 12 kilometers down a river. The return trip against the current took 3 hours. What was the average paddling rate of the canoeist? What was the speed of the current? Okay, so basically what we have is the following. Let's, as always, it always helps to do a sketch. It always helps to do a sketch of this situation, right? Let's underline the important stuff first. It says 2 hours to travel down 12 kilometers, right, of this river. And then the return trip against the current, it took 3 hours. So basically up the river, it took 3 hours and you're traveling the same distance. Okay, so let's do just a rough sketch here. Let's say this is the river bank. So here you have a canoeist. Alright. Okay. And you have the current of the river going this way. Right. And also you have the paddling rate of this person. So let me actually put different colors for this. So here's the current, right? And let's label current with the letter C. We don't know what the current rate is, but let's label it with the letter C for current. And then the paddling rate here of the canoeist, let's label it with the letter P. Okay, so in fact let me choose a different color here. Alright, so and let's put up paddling for this guy. Okay, so here, so he's going down the current and he's paddling at this rate. So of course, if he paddles in the same direction with the current, he's gonna add to that speed. So now let's create an equation for this situation, right? So once again, 2 hours to travel 12 kilometers down a river. So we can say that the canoeist was paddling down the river, and with the help of the current, right, leave a little bit of space here, he traveled a total of 12 kilometers. Now we need to take into consideration the number of hours. So it took him 2 hours to travel down the river. So that means we can do what to show that? Well, we multiply this times 2, right? 2 hours. Okay, so that's our first equation. And then the other equation says that he traveled, it took him 3 hours to travel up the river. So that means that when he was going up the river, he was basically facing the other way, right? So with a paddling rate of P. So now how do we show that, right? How do we show that? Well, there are different ways. We can say the following, that he was paddling, right, but the current was going against, in an opposite direction to the paddler, right? So we can say that the current was going in the opposite direction. We can show that with a minus sign. It traveled the same distance, 12 kilometers, but this time it took him 3 hours. Okay, so that's our second equation. So now once we have these equations, we can use it to solve our to find out the speed of the canoeist and the paddling rate for each of those. Okay, so once again we label the equations, and probably the first thing we might want to do is actually to expand them. So let's do that right now. I'm going to expand equations 1 and 2, and this becomes 2 times P becomes 2P plus 2C equals to 12 kilometers, and here 3 times P, 3P times negative C. So 3 times negative C gives us negative 3C equals 12 kilometers. Okay, so now we need to use either the method of elimination or substitution. I am going to use the method of elimination, and I'm going to start by eliminating P. So that means I would have to multiply each of these by a certain rate. So I'm going to multiply equation 1 times 3 and equation 2 times 2. So we're going to end up with new equations. I'm going to use green for our new equations, and then I'm going to start solving the problem using that information. So 3 times 2p gives us 6p. 3 times 2c, that gives us 6c. And 3 times 12, that gives us 36. 2 times 3p, that gives us 6p. This, here we get negative 6c, and here we get 24. Okay, so now what I can do with these two equations, I can subtract each of these in order to eliminate p. So let's do that. So equation 1 minus equation 2. 6p minus 6p, that gives us 0p. I'm not going to write it down. And here, plus 6c minus 6c, that gives us 12c. And 36 minus 24, that gives us 12. Now, in case you're wondering here, what we're doing is this. Right? In case you're wondering, right? Remember your integer operations. What is happening essentially is the following. We're doing 6c minus 6c, which becomes 6c. This becomes positive 6c, that becomes 12c. Okay, this is exactly what happened here. Okay, in case you're wondering, I don't know if I needed to show that, but in any case, so now we need to solve for c, right? 12c equals 12, so therefore c equals to 1, right? Because 12 divided by 12, that gives us 1. Okay, so that's the speed rate of the current. Now with this, we can find the speed rate of the paddler, of the canoeist. So we take this and we substitute it into one of the equations. I'm going to choose to substitute c equals 1 into equation 1, right? It would work even if you substitute it into equation 2. So let's do that. So sub c equals 1 into equation 1, and we get the following. We get 2 times p plus 1 equals 12. Now this becomes 2p plus 2 equals 12. And this becomes, I'm running out of space here, this becomes 2p equals plus 2. When you move it to the other side, it becomes minus 2. So 12 minus 2, that gives us 10. Therefore, p is equal to 2 is multiplying, it goes dividing. 10 divided by 2, that gives us 5. Alright, so the paddling rate of the canoeist is 5. And let's write down our conclusion here. So therefore the paddling rate was 5 kilometers per hour, and the current rate was 1 kilometer per hour.